Okay, so we're given this fourth degree polynomial function, and the question is, where are we increasing, where are we decreasing, and are there any relative extrema? And if there are, what kind of relative extrema are there? So step one is to derive. So when I derive, I get 12x cubed minus 12x squared. Step one is to derive and set the derivative equal to 0. So I'm going to do that by factoring out a 12x squared. And when I do, I get two solutions. One of them is 0, and one of them is x equals 1. Now, why are these x's so important? It is because they are called critical points or critical numbers. And the reason that they are critical, the reason they are important, is because they could be the relative extrema that I'm looking for. So this is your step one. Derive, set the derivative equal to 0, solve for any critical points or critical numbers. Once you have the critical points, step two is to put your critical points on a number line, your critical x's, and then to use the derivative f prime, which I put here in this pink box, to make yourself a sign chart for f prime. So you can pick any number that's less than the very first critical point. So I'll pick any number that's less than 0, like say -1, and I try to determine the sign. When I plug in -1, I get a positive number times a negative number, which is negative. And then I repeat this process for all the intervals I've created. So now I pick a number between 0 and 1, like 1/2. I plug it in here. I get positive times negative, which is negative. In fact, this first term, no matter what I plug in, is always going to end up being positive, right? Because anything quantity squared is positive. Anyways, I'll take another number like 2. I'll plug it in here. When I plug in 2, I get positive times positive, which is positive. So now, the way you can tell whether or not critical points, critical numbers are extrema, is only once you have made an f prime sign chart. If I have a change of sign, I will have an extrema. Do I have a change of sign here? No, I don't, because I'm going from negative to negative. There's no change. Do I have a change of sign here at x equals 1? Yes, I do, because I'm going from negative to positive. If you have a change of sign, you have a relative extrema. Depending on how the sign changes, you either have a min or a max. Since I'm going from negative to positive, my shape at x equals -1 looks something like this, from decreasing to increasing. So therefore, this relative extrema is a relative minimum. Okay, so the question is, what's going on here at x equals 0 then, if there's no sign change? Well, the signs tell you the behavior of your function. For example, you know that your function starts off decreasing, starting at -infinity, till it gets to 0. And then, between 0 and 1, it continues to decrease, and after 1, up to positive infinity, it increases. That's what the signs tell you about f. So because I'm going from decreasing to decreasing, my shape looks something like this. I'm going from decreasing, and then I continue to decrease. And I informally call such a point as a drag. So it's not an extrema, it's not a min, it's not a max. Another point here is, since my derivative had only a numerator, all my critical point values were 0. If my derivative had a numerator and a denominator, then these, if I got them from the denominator, would not be 0, they would be d and e, which will give you further information about the original function. All right, so step 1, find f prime, set it equal to 0, solve. Step 2, make a number line. And the number line will give you everything. Intervals of decrease, intervals of increase, and any potential relative extrema, including descriptions of what's not an extrema. All right, and then that's the end of step 2. Okay, on the advanced placement test, they don't allow us to use number lines as justification on free response. So what they want you to do is they want you to translate the number line, even on the multiple choice, into interval or inequality notation. So they would want you to write your decreasing intervals as interval from negative infinity to 0 and from 0 up to 1. These are my intervals of decrease. My interval of increase is from 1 up to positive infinity. That's my interval of increase. And then they also want you to list out any relative extrema. So I only have 1. At x equals 1, I have a relative extrema. More specifically, I have a relative minimum. So usually your final answer is only acceptable in this notation, and the sign chart is not acceptable. Okay, and then let me show you the inequality notation. So the inequality notation, an equivalent notation to this is negative infinity less than x less than 0, and then 0 less than x less than 1. These would be my decreasing intervals. Okay? So this is interval notation, and this is inequality notation. And then one less than x less than infinity for my increasing inequality notation. If I want to figure out the y-coordinate, I can. It didn't ask for it in this problem, but if I want to figure out the y-coordinate, I just take my original x, plug it into my original y, and I get 3 minus 4, or I get the exact location, see that, of my relative minimum. Okay, so step 1, derive set equal to 0, find critical points. Step 1, find critical points. Step 2, make a sign chart. Step 3, translate your sign chart into interval or inequality notation. Okay, now this is actually what you figured out. You figured out that at 0, see that? And at 1, something special was happening. So at 0, 0, you then figured out after you made a sign chart that there's a drag. So see the drag you claimed to be at 0, 0? There it is, right there. And then at 1, comma, negative 1, you said that there would be a relative extrema. And in fact, there is a relative extrema right there. Okay, the next thing that f prime gives you is it gives you the entire increasing, decreasing behavior of the function from negative infinity up to positive infinity. So from negative infinity up to 0, you're decreasing. Then for a moment, you have a horizontal tangent line there. That means you kind of freeze there for a second. Then you continue to decrease. So see how it says that here in the sign chart? It says decrease, a momentary hesitation, and then more decrease. And then starting at x equals 1, which is right here, you start to increase forever up to positive infinity. So the sign chart is a very, very powerful tool for f prime to describe the behavior of f. And that's what you got to remember. F prime gives you more information about f than just simply algebra would have.